Start the recording. New operation.
No.
Okay, pause there. You don't have to write anything for a minute because I want to tell you a story. Story time. Let's take our factoid. I alluded, I'll try to make this fast, guys. Let's pay attention, it'll go really fast. I alluded to this yesterday, that if you want to get this 5, we have no operation for that. And the way that mathematicians dealt with this at first was they would write, please, may I have the exponent on a base. What's the base? On a base of 2 if the power is 32 equals, gotta zoom out a little. Okay, what is the, oh, go away little zoomy thing. Come on, get out of there. Okay, so if the base is 2 and the power is 32, what is the exponent? A 5. But this sentence is long and annoying. And so the mathematicians who discovered these things, they didn't have the word exponent. All that they knew was that this number, this little number, was helpful. It was helpful to them. And so they came up with a word that meant like basically like little buddy, little helper number, my little reasoning friend, my little number. But why was it helpful to them? Well, let's go on a journey. What if I had 32 times 64? Okay, this is not the worst problem ever, but how would you do this without a calculator? And pretend these are bigger numbers. Pretend it was like 3,700 Kriya. Right? Like, what would you have to do? 2 times 4 is 8. 4 times 3 is 12. Now move over to the 10, so I gotta put a 0 here. And 6 times 2 is 12, carry the 1. 6 times 3 is 18, plus 1 is 19. And then you're not even done. You have to add all this up. 4, 0, carry the 1. It's 2,048. We can do this much faster with our helper buddies. Because 2 is 2 to the 5th times, what is 64? 2 to the 6th. And Josue, what is 2 to the 5th times 2 to the 6th?
I don't know, bro.
Okay, I don't want you to say I don't know, I want you to say I'm interested.
Wait, it's two. You gotta add those, right?
Yeah, add them up, that's right. 2 to the 5 plus 6, which is 2 to the 11th. And of course, everybody knows 2 to the 11th is 2,048. Now maybe you didn't know that, but you are supposed to know that 2 to the 10th is 1,000 and what? Oh, I forgot. 1,024.
How do you forget that?
I don't know, I just brain fart. Okay, so it's 1,024, and if you double that, it's 2,048. Okay, so what's faster? Doing all of this multiplication and addition, or doing one addition? Yeah, so this is why they thought these numbers were little helper buddies. And I told you yesterday it was Latin. That's wrong. I'm sorry, I looked it up. It's Greek. Logos is logic or reasoning in Greek, and number is arithmos. And arithmos is number. Arithmos. So the reasoning number or the logic number, the helping number, is the logos arithmos. Turns out even that is too long to say, and so it's been shortened to logarithm. There's no vowel between the H and the M, which is weird. Just logarithm. What is the logarithm? It is the helper buddy. But what do we call that little number? The exponent. So you'll hear people say this all the time. Logarithms are exponents. The log, when you find the log, you have found the exponent. We now have 2 words for exponents. You can call it the exponent or you can call it the log. You basically use it in different contexts. When it's on something, it's an exponent. When you've taken it off the thing and it lives on its own, but it used to be an exponent, now it's the logarithm. Okay, so that was all optional notes. I hope you didn't write all that down.
Bro, are you kidding me right now?
You wrote it all down?
Yes.
You did not.
Yes, I
I can
did.
see your
Look.
paper, dude.
Psych.
Mr. Evans, to be fair, you never actually said that those were optional.
He did.
notes.
He did.
He did.
Weren't listening? I'm just kidding. Okay, where do the real notes start? They start here somewhere. Here we go. Okay, here it is. So, new operation. All you were supposed to have written down was new operation.
B's and A's. Basically B plus and
The operation that gives the exponent
something almost 3.0.
for a particular base. Let's wait, listen. For a particular base is the log operation. No, remember it stands for little buddy, the reasoning number, the Logarithms, the logic number. Strangely enough, the word coefficient basically also means little helper number. So coefficients and logarithms are just numbers that help us out. Okay. How do we do this? Let's do some examples. Now remember that big log sentence I wrote earlier? Basically, mathematicians have shortened it down to this. The log base 2 of 32 is 5. The exponent on a 2 to make a 32 is a 5. This little 2 is a subscript, so you write the word log, normal size, then you write a little 2 down low, that's the base. Then you write the power that you're interested in. I want to get to 32. What's the exponent? What's the log that will get me there? The log is 5. How about log base 10 of 1,000? Remember, this little word log, it stands for please give me the exponent on this base if I'm trying to get to 1,000. So please give me the exponent on a 10 if I'm trying to get to 1,000. Shante, a 3. Okay, that's how logs work. Now you might be wondering, well, why do we still write this little word? Well, basically, these were the most recent, this was the most recent operation to be discovered. And for a while, they were just writing a sentence. And the sentence got shorter and shorter and shorter until it was just log. And then someone said, hey, we should really come up with a symbol for this. And they were like, we already did. It's log. That is the symbol. So, a little funny, but we get used to it. Where's the assignment? Jack, would you get that? Hey, welcome. Okay. Okay, 6th period is still going on, but I'm going to try to finish this recording. Let's see if I get my microphone figured out. Don't worry, that's natural. I will get it back. Maybe. Booyah. Okay, sorry about that. All right, here we go. Okay, so we know that the log means find me the exponent on a 13 if it makes a 169. And we know that 13 squared is 169, so the exponent must be a 2. Therefore, rewrite each equation in exponential form. 13 to the 2 is 169. So these are two different ways of writing the same fact. This fact says the exponent on a 13 to make a 169 is 2. And this fact says the exponent on a 13 is a 2 if it makes 169. I'm going to do the problems on the left, and you're going to do the problems on the right. Okay, but what's the exponent on an 11 if it makes a 1 over 121? Well, how do we flip things over and make tiny fractions? We use negative exponents. It's be a negative 2. So 11 to the negative 2 equals 1 over 121. Okay, but what's the exponent on 17 if it makes a 1? Well, I know that 17 to the 0 is a 1. Therefore, It's a 0.
No.
Okay. Now, all the information is here. We're just rewriting now. Log base 7. The 7 is the base. The power is 49. Now that's, if you weren't here the day we discussed this, it's unusual. We don't usually talk about the big number as the power, but if you think about it, we say the second power of 7 is 49. This is the second power. It's the power. This is the power. That's the exponent. It makes the power. The second power of 7 is 49. 49 is a power of 7. The second one. Therefore, the exponent's a 2. Log base 18 of 324 equals 18. And log base 11 of 1 is a 0. Oops. Log base 11 of 1. Well, what about log base 11 of 11? Well, what's the exponent on an 11 to make an 11? It's a 1. Remember, log means give me the exponent on a thing if I make a thing. Or sometimes you'll hear people say, let's go do one over here.
What?
13 to the what is 169? 13 to the tooth, or squared. And lastly, this is like the top section, except they're telling you the exponent. So here, ergo, 3 is the base, the exponent is a 4, and it makes an 81. B is the base, the exponent is a c, right? The log is c, that means the exponent is a c, because logs are exponents. Oh, that looks stupid. B to the c, that looks better, equals a. Alright, have fun. Nailed it.